Hello, welcome to Coffee Break with Microchip Technology. In fact, welcome to our 10th season of Coffee Break, just getting started. Coffee Break is our ongoing forum in which we discuss new and evolving technologies, all in about the amount of time it takes to drink a cup of coffee. I'm your host, Eric Glatfelter. Let me introduce Aliyah Fahoud, our moderator.
Thanks, Eric. Hi, everyone. Welcome back to Season 10. We are currently live on YouTube, Facebook, and LinkedIn, and you can participate in today's episode by leaving your questions and comments in the chat, or you can email us at livestream@microchip.com after the broadcast. Don't forget to follow, like, and subscribe to our social media platforms as well. Back to you, Eric.
Thanks, Aliyah. Joining me in the studio today is Alex Lee, Product Marketing Engineer here at Microchip. Our topic today is Wi-Fi bridging for industrial applications. So Alex, first of all, welcome to Coffee Break.
Yeah, thank you, Eric. I'm glad to be here to introduce the Microchip's the bridging technology, what is that and how it can help our customers.
Yeah, great to have you here. So let me focus in on these first two words of our topic, Wi-Fi and bridging, which seem pretty simple words. But first of all, let's talk about Wi-Fi. Now, in an industrial application, there's lots of networking going on. So why would somebody want to add wireless to a piece of equipment in an industrial application?
Yeah, so you can see the Wi-Fi is being used more widely now. Whatever from home automation, your laptop, your mobile phone, and now you can see some applications in the industrial, and so the people can use the Wi-Fi to do the maintenance, and diagnostics for the machine. And the benefit of the Wi-Fi, of course, is it is very easy and flexible to install and set up the whole process. So if the machine support Wi-Fi, I can just use even use my mobile phone to connect to the machine, and I can read the information, collect some key data, and upgrade firmware. But let us see if this machine only has the Ethernet. So I have to use my laptop and the cable. So this is some extra code for the cable. And now you can see not all the laptops support the Ethernet part. Do you have one in your laptop? I don't think so, right?
Right.
Yeah. Sometimes the Wi-Fi make the calibration, make the maintenance more flexible and easier. And yeah, so that is the advantage of the Wi-Fi.
Now, whenever we talk about wireless protocols, I always ask, why this wireless protocol? So with all the wireless protocols that are out there for industrial applications, what it is about the Wi-Fi protocol in particular that makes it good for industrial applications?
Yes, there are several features for the Wi-Fi that make people love it in industrial area. So the first one is the Wi-Fi is the high power radio frequency technology. That means your RF transmission power is high, and that is a good thing for the very noisy environment. Like for example, in the factory, you have the metal, you have the machines, you have the noise everywhere. To make the whole environment that's full of the interference, and under such conditions, so Wi-Fi with high transmission power can better handle all of this noise. And the second feature for the Wi-Fi is it can directly connect to the internet. That means it connect to your mobile phone, connect to your laptop, connect to the home your router, and yeah, so it can connect directly to some the devices we have now. And yeah, sometimes the people think about via Bluetooth, but if for the high transmission speed, so Wi-Fi is preferred.
Good combination of capabilities there for the application then. So, let's talk about now the second word, bridging. So this isn't a civil engineering world where we're building bridges. This is a electronics engineering world. So what does bridging mean in this networking environment?
Yeah, so the bridging means it connects two different parties. And today we talk about bridging is to connect the separate network. So for example, this side of the bridge can be the Ethernet, can be the CAN bus, a protocol like that.
Okay.
And the other side of the bridge can be the Wi-Fi, that is another protocol. So from the wire to wireless.
Wire to wireless.
Or
okay.
just the different protocols.
Yep.
So yeah, so bridging, I have to say, that is the fast way, the easiest way to enable wireless connectivity. Because usually there are several ways if you want to enable a wireless connection on your machine, on the product you are designing. The first is use bridge, and the second one is to integrate a Wi-Fi module.
Okay.
So how do we compare this? Let me ask you a question.
Sure.
So if you are driving your car and if you want to go to the other side of the river, you can choose several options through the bridge and change the boat, or you just swim there, whatever style you want, butterfly or freestyle. But which one do you prefer?
Well, speaking for myself, I'm gonna say the obvious answer would be to stay in the car, right? So if I'm already driving, I want to keep driving. Plus, I've got all my creature comforts. I've got my air conditioning, very important here in Chandler in July. I've got my radio.
Yeah.
So so that seems like the simplest thing.
Yeah, exactly. So if you drive the car through the bridge, and you don't need to get off your car, and you don't need to learn how to swim or learn how to drive a boat.
Right.
So you don't need to do anything.
Yeah.
So that is the benefit of the bridge. And let's come back to the system design. So because the bridge can connect to different protocols, the meaning of that is the host processor or the host machine can continue use the existing protocol it has. I mean, let's say I am the microprocessor and I am using the Ethernet. With the bridge, that means I just keep using Ethernet. Okay. I stay in my car, and I don't need to worry about both. And the processor doesn't even need to know it is talking to a Wi-Fi. Okay. Doesn't need, just to keep using Ethernet. Yeah. So that is the advantage of the bridge. Okay. So the Wi-Fi module is a different way. So the Wi-Fi module is you have to change to a boat. That means you have to learn how to drive a boat. Right. And you have to drive a boat.
And build a boat.
Yeah.
Somebody's got to build that
yes. boat. So that means from the system design level, that means you have to develop the driver. Use the Wi-Fi language to talk to a Wi-Fi module. That means you have to redesign your system. Okay. Yeah, so extra work and knowledge needed. Okay. Okay. So with this, you can keep your focus on your piece of equipment and the wired networking that you're using inside that piece of equipment. Yes. Okay. Awesome. So can you tell us more about, we've said industrial applications, but can you give us some examples of use cases and things where this might be particularly useful? Yeah. Well, first of all, I want to mention is, so we talk about a lot about the Wi-Fi and advantage of the Wi-Fi, but the wired solution is still needed in the industry because it's the low latency, highly reliable, and in most of the applications, the people still want to use the Ethernet or the CAN bus. But they still need to use the Wi-Fi to do some work like the calibration, system upgrades, or the diagnostics. Okay, so these are things that would run periodically, not all the time. Yeah, so that means the customer has to keep their wired solution, but sometimes use Wi-Fi. Sure. So that is why we brought up this bridging technology. That means you can keep your Ethernet, but sometimes you can bridge to the Wi-Fi. Okay. And the typical application, a very interesting story is some customer is designing the gambling machine in the casino, and they develop very small the device to upgrade the firmware or the system of their gambling machine. Yeah. And So this is the bridging device. That means this side is the host and the host machine, the gimbal machine, and the other side is the laptop. So from the laptop side, I can do the diagnostics and the upgrade system.
Right.
And another example is in the automotive industry. So sometimes when you drive your car for service, you can see the worker has the handheld, the CAN bus reader.
Sure.
Plug to your car and read all the informations, your filter, your the engine oil, these kind of things. But for some more advanced diagnostics, so the workers have to use the laptop.
Yeah.
And how to connect the CAN bus to the laptop. So sometimes they use the bridging. This side is CAN bus, the other side is Wi-Fi.
Right.
So the Wi-Fi you can use the laptop connect to your car through the bridge through the Wi-Fi and do the more advanced system analysis.
Yeah. Okay, so that's an interesting example in the automobile because they're not only using a wired protocol, they're using lots of wired protocols. Right?
Yeah,
you've got
exactly.
LIN, you've got CAN, you've got Ethernet, you've got maybe have PCIe, many wired protocols.
Yeah.
Okay. Okay. So and my laptop doesn't have CAN bus as we talked about. So
Yeah, your laptop any wired.
right.
Yeah.
So let me jump back to the gambling machines too for a minute. I was thinking
Yeah.
it's kind of an interesting thing because that's a piece of equipment that's very highly regulated, right? So so how people interact with that machine or update it is very highly regulated. There's a lot of documentation, but I'm thinking that to open up a piece of equipment like that is even more more highly regulated, and there's probably an overhead of documentation and things like that. So if you can avoid opening it up, it's probably a good thing. Just from hours of maintenance and things like that. I'm thinking that might apply to other use cases like very highly sophisticated medical equipment, for example.
Yeah. The medical equipment is sometimes is also the equipment is expensive as
Yeah,
car,
very
actually.
expensive.
Yeah, and you really don't want to say don't want to see is the patient is sitting there and receive some treatment, but there's another guy sitting on the floor and use the cable connect to
Right.
don't worry about me, I'm doing the calibration.
Yeah, don't mind me.
Yes, yeah, but sometimes you can connect to the Wi-Fi to the equipment and do some work remotely. So
Yeah.
Yeah.
Okay. Interesting stuff. So if somebody wanted to learn further and get started learning more about the Wi-Fi bridging, where would they go? What should they do to get started?
Well, yeah, we provide some fantastic stuff for customers, and I believe if you are a technical nerd, you will hate this, because it's really very, very easy to implement.
Okay.
That you don't have an opportunity to demonstrate your special talent. So so the first thing we provide customer is the turnkey software, the bridging software. So the customer can just download the binary and the run function. So that means they don't need to do any kind of the coding or something.
Yeah.
And we provide some development board for the customer to evaluate the function. So very straightforward, just to purchase and plug together, and you can demonstrate function.
Yep.
And since the microchip we not only provide Wi-Fi, we also provide Ethernet, Ethernet PHY, or the CAN controller, all of these other components. So we can provide customers the support from everywhere about questions.
Okay.
And yeah.
Okay. So we've got the hardware obviously, but we've got development tools and code as well to help get over that initial setup and reduce maybe some of the time needed to add a bridge.
Yeah.
Okay. Awesome. Well, thanks for that overview, Alex. Let's go to Aaliyah and see if there are any questions from the audience today.
Yes, Eric, we do have a few questions for you today. The first
good.
one we received is from LinkedIn, and it is, can this be used for battery-powered applications?
Can you repeat again so I can hear clearly?
Yeah. Yeah, can this be used for battery-powered applications?
Uh, well, you can use it for the battery power application, but the thing is, the Wi-Fi is high power transmission technology, so that means that it will consume a lot of power. So my 2 cents for this kind of the designer of this system is, yeah, you just turn off the power when it is not used. Yeah.
All right, second question for you is also from LinkedIn. What security options are available to protect the Wi-Fi nodes, and does the bridging affect the wired network's performance?
From the security side, I think we provide the standard Wi-Fi security. Like if my laptop want to join the Wi-Fi, our bridging device, it has to follow the standard Wi-Fi security like the WPA3. And suppose the bridging device is accessing point, and my laptop want to join and need the password and everything, yeah, needed for to join the network. Yeah.
Okay.
Great. And we do have a few more questions that we received via email. What is the difference between this solution and simply adding a Wi-Fi module to my device?
Yeah, as I mentioned before, yeah, let's come back to the river story. I really like the river story. So the the Wi-Fi module is a boat. So it means if you want to add the Wi-Fi module, you need to write driver, and you need to understand how to drive a Wi-Fi module. So that means you need to know how to drive a boat. And but with bridge, so you don't need to do that. So don't need to recognize the Wi-Fi module there. So you just keep using your existing protocol. Yeah.
Great. And another question for you is, you talked about using bridging in industrial applications. Can it really hold up to the noise and interference common in those settings?
That's really the case by case, right? So I have to say, for some application scenarios, um, it is good. The Wi-Fi can hold the noise level, but for some application scenarios, the Wi-Fi cannot. That is why, sorry, some water.
No problem.
So that is why our customers still want to keep their wired solution, because the wired technology can handle most of the noise. But sometimes, let's say, in the factory, when all the machines stopped, it's quiet, a little bit
Quieter.
Yeah. So we can do some calibration, we can do some system maintenance. So for such kind of scenario, we can use Wi-Fi. Yeah. But usually for the industry applications, the Wi-Fi and the wired used in parallel. And yeah.
Great. And another LinkedIn question that we received is, can we use a IIoT gateway application?
I don't see any issues to use there, I think, yeah. Yeah, because our Wi-Fi product is really industrial friendly, especially the Microchip's product, because our Wi-Fi product is really robust. That means we keep the stable RF performance under different temperatures, and we have the reliable software proven to work. So all of these are really the industrial friendly.
Okay.
Yeah.
Okay, great. I believe we have time for one more question. This is from LinkedIn, and it is, can this be used for wearable devices?
Yeah, it can be used in on the wearable devices, of course. Yeah, but the thing is, maybe to go back to the first question, is the power management. So it means when the device is not in use, turn off your Wi-Fi and put the device to the deep sleep and save power. So then you can have a very long battery life.
Thank you, Alex. Those are all the questions I have for you today. And again, thanks everyone for tuning in today. If you have additional questions or comments, please email us at livestream@microchip.com after the broadcast. And don't forget to follow, like, and subscribe to our social media platforms. Back to you guys.
All right, thank you, Aaliyah. Thanks again, Alex, for joining us today and sharing your expertise. Thank you to our audience for taking some time out of your day to watch our episode today. If you enjoyed that, please visit us at microchip.com/coffee break. You can see our recently posted schedule for season 10. You can subscribe for updates and post things to your calendar, and you can peruse our library of previously recorded sessions. Thank you again for your time. See you next time.